Okay, for now we're going to talk about biased versus unbiased questions. This is probably the most important thing that you should really look at when you're actually seeing data in real life, whether it's on the news or online. Make sure stuff is not trying to sway your opinion in a certain way. If not, it's not necessarily a good question. So if a question is biased, revise it so it can be asked in an unbiased way. So biased versus unbiased is where biased is it tries to force your answer in a certain way. Unbiased means it is a neutral question. The answer should not be swayed by how it's worded. So number 22, do you agree that rap is the best genre of music? So usually that line, do you agree, automatically makes it biased in the get-go. It's think about who is asking you the question. They might be trying to sway you into saying rap is the best music. So how do you revise a question to make it unbiased? Make it as almost as boring and lame as you possibly can. So maybe a way to revise this, and there's multiple answers, might be, what is your favorite genre of music? And that would make it an unbiased type of question, no sway in any direction. Like 23, what is your favorite kind of animal? Well, does not sway. Wouldn't be my question where I said, man, don't you think cats are better than dogs because they kill vermin? Um, nah, what's your favorite kind of animal? Does not try to sway you in any direction. This is the example of an unbiased question. What is your favorite color? Once again, there's no sway. The question does not say, do you agree blue is the best color ever? Um, what is your favorite color? Boring, very unbiased. And then 25, do you think cigarettes should be illegal since they cause people to stink and get cancer? Okay, there's a sway if there's anything. Even if you don't like cigarettes, that's not the point. The point is, does this try to sway someone from saying things? So, answer for 25, and I'm going to write it up here. This is the definition of biased if I've ever seen it. So, do you think cigarettes should be illegal? You probably shouldn't say, do you think cigarettes should be illegal? That would still make it biased because the do you think is just kind of a play off, do you agree? So, you could ask, there's multiple ways to do this, but what's your favorite genre of music? You'd be like, what do you think of cigarettes? Or another way, and I don't know if I like this one. You might say, yeah, what do you think of cigarettes? Another way to write it maybe, um, what is your opinion of the legality or illegality of cigarettes? But that's longer winded. So just know you want it plain, you want it simple. It's like eating a burger without the toppings, just plain. It gets the job done, but it doesn't add anything to it. Um, so, with that being said, I just want to go ahead and we're going to move on to qualitative versus quantitative data. And another name for qualitative is categorical, another name for quantitative is numerical. So, what's the difference? Uh, think of qualitative as more of a label, um, where quantitative is numbers, and this is the big thing, numbers you can do um, arithmetic math with. Um, think of like mean, median, mode. Um, well, I'm not going to put that, but numbers you can do actually arithmetic with. Like, can you find the average? Can you find the median? Can you find the sum of them? Can you do actual math with the numbers that actually mean something? And so, if the answer is a number, it might still be qualitative, but if the answer is just plain old words, that's nothing to do with numbers, then it's definitely going to be qualitative. So, tell whether each variable is a categorical, qualitative, or numerical quantitative. So, your favorite movie. In and of itself, your favorite movie is going to be a label, it's going to be a name. Your answer is in words. So, this would be technically qualitative. Another word for it would be categorical. Your age. So if the question was your age, you asked 20 people their age. Could you find the average? Could you find the median? Could you find the mode? Could you do something with those numbers? So since you can do something with the numbers, this would be technically quantitative, or another word for it could be numerical. Same thing with height. You could find the average height of a group of people. You could add up the heights, and the numbers would have some meaningful math with it. This is also numerical / quantitative. And last but not least, a zip code. Now the issue is zip code is technically a number, but can you do meaningful math with it? Can you find the average zip code by adding all the zip codes up and dividing by number to where that zip code actually means anything? Not all numbers represent quantitative data. Sometimes numbers could still mean qualitative, because technically a zip code is a label. It labels where you live. So zip code is technically qualitative, or the word I prefer is technically categorical, but they are both mathematically sound. So since this video is still sort of short, let's go ahead and move on with the difference between discrete and continuous data. Discrete data has a set value, or it's also stuff you can count. You can't have any weird nuances in between. You go in increments. So if you count a amount of paper, like I have in front of me, I have like 2 sheets of paper. There's not 2.5 sheets. It's still just paper. Probably not the best example, but I can't think of anything off the top of my head that's not on this page. So set value, usually anything you count will be considered discrete, where continuous data can be any value or any set in between. Usually anything you measure will be continuous, but it could be of any value, any decimal places in between. There's not necessarily a set. If it's something that you say, well, you got to round to the nearest 10th, that's continuous. And that's probably a way I should have described it back in the day, but we're here now. So number 32, is this discrete or continuous? Number of desks in the room. You technically count the number of desks in the room, and even if there's some chip marks off the desk would be in set increments of 1. 1 desk, 2 desks, 3 desks, 4 desks. So that would be discrete. Your age. Now, once again, age can set different values, months, years, time. Literally I am closer to my final days just by doing this video. Age has increments in the middle of the set increment. So your age is technically continuous. You measure your age. And these two are my favorite questions. Your shoe size. Now shoe sizes, I'll think about it this way. You might have shoe sizes that are in the middle. 10, 10 and a half, 11, 11 and a half, so on and so on. 12. But the issue is there is no 10.25. There's no 10 and a fourth. There's no middle increments. There's no scale. There's no measuring tape here. Your shoe size is a set value. So a shoe size is discrete. But your foot size, one person's foot size might be 12 and a half inches. Another guy's foot size might be 11 and a half inches. Some people might have small feet. I don't know, 6.5 inches, 6 3/4, 6.8, whatever. Your foot size can make any value that it wants to be, so this one would be continuous. Alright, I like making long videos, so we're going to just go ahead and continue with this one. Difference between a census and a sample. With a census, you ask everyone, and a sample, you ask for part of the population. So this is where I'm not going to go full the definitions with population, but we'll talk about it informally here. If you want to see the full notes, you need to go back to, I believe it was 7.1 or 7.2. Not set, Unit 7, this is Unit 6. So, random question. This is, I think, very similar to the one we did in class. Determine the average grade of the Unit 7 test of his students. In his Math 4 class, Spencer Taylor will grade all the tests and then find out what the average is. Population of the scenario is who the study was about. And this would be Mr. Taylor's Math 4 class. Or his Math 4 classes. Depends on the year. So does this represent a census or a sample? Now just a reminder, census is everyone, sample's part, but since this is all of my Math 4 students, this is technically a census. Now if this was a situation where I only asked part, then it would be different. But does this information represent a parameter or statistic? Just a reminder, statistic goes with a sample, a parameter goes with census. So census is from a census. This would be a parameter. And then we are done until we get to the next type of question, which will be back here. And I say, since these will take a little bit longer to explain, I say we stop this video, let you process, take a deep breath, and get ready for the next one, because this will involve some extra notes just to get you guys a little bit through what the different sampling methods do. So, yep, stopping the video now.